Hello, this week we're going to start chapter 18 where we're going to look at statistical applications in quality management. This chapter is an online chapter, which means that it is supposed to be available through the publisher's website along with the files that you need to work the problems. However, I can't seem to get hold of either of them. So what I've done is under course materials on Blackboard, down near the bottom, you will see chapter 18 as a PDF of the chapter. If you click on it, you see the book, the whole chapter. You can just print it off or read it online, whatever you usually do. And in addition to that, there is a whole section here with the Excel files that go with all the problems in this chapter. So you should be able to just click on one and it should open up. Anyway, that's where the files and the chapter is at for the material. I don't need that anymore. So what we're going to cover this first week in chapter 18 is we're going to talk kind of in general terms about control charts and the theories of control charts, where they come from, how we use them, how you create them, and then we're going to create a P chart, two P charts, and a C chart, which will make sense to you as we kind of get into it, I hope. Anyway, next week, what we're going to do is we're going to finish up chapter 18 by looking at charts for measurement data, which are X-bar and R charts, as well as process capability. And that'll be the last of the material for the semester. Anyway, so chapter 18, basically, the background of this, you can read this in the textbook. It's got a lot of material in there that we do not cover in this video that relates especially to W. Edwards Deming and Six Sigma programs and Schuhart and a lot of the people in quality and Six Sigma who are very important in helping to develop what we consider control chart theory these days. But the origins for all of these tools came out of Bell Labs, work done in 1920s. They were trying to handle processes, and Schuhart was the big name there who developed what we know today as control charts. There were two other statisticians at Bell Labs, Dodge and Romick, and they developed the theories of statistical sampling. So when you pick sampling sizes and things, that's where a lot of that work came from. But today we mostly look at control charts. So there are so quality control, we're looking at process control down here that was developed by Schuhart. Acceptance sampling came out of Dodge and Romick's work. And again, you can just read this, but the theory is that if you can basically make adjustments to a process as it's running, you never have to shut it down because you're going to catch problems before they become big problems and you produce bad items. As far as measures go, there are two kinds of things we measure with control charts. If all we're doing is looking for defects, then we're looking at attribute measures. It uses a binomial distribution. It looks at proportion of defectives usually. I think in this chapter we look at a P chart, two P charts and a C chart. And I should have put that in there. Let me fix that while I'm here. So when I put the copy over here, it'll be right. And I should put a space in there. Anyway, so those three kinds of charts, and then that's what we're going to look at this week. Here, with attribute measures, all you're looking at is good, is it bad? Variables measures are a little more complicated. They look at the amount of the deviation that you have in the measures you're taking, and it has to be something that you can measure, like weight, thickness, length, and these are where we use our X-bar and our R charts. I do not know spacings. Anyway, our X-bar and our R charts, and that's what we're going to cover next week, along with process capability. Statistical quality control looks at variability in processes, and I would tell you that the theory tells us that every process has variability. It's expected. You shouldn't be surprised to discover we have variable processes. So these two kinds of process that we divide and talk about, at least in this textbook, there are other kinds. I think if you got into engineering process control, it get a little more complicated. But for our purposes, we look at something called common cause variability and assignable cause variability. Common cause variability is due to random error. Every process has that variability. It always exists. If you're making 100 products a day in a manufacturing environment, there's going to be some variability somehow, some way in those products you're producing. Assignable cause variability is a whole different thing, though. This is due to a specific problem. Usually we kind of divide it up and we say it's due to something related to the materials you're working with, the machinery you're working on, or the worker who's doing the work. These things can have to be corrected and have to be corrected if you're going to use control charts. But anyway, so and the first phase, step in building a control chart is to determine whether you have assignable cause variability that would prevent you from using a control chart. So until you get rid of it, you can identify it, but until you get rid of it, you cannot, actually use a control chart on a day-to-day basis. Read it back through the book. It'll make more sense, hopefully. Control chart construction steps. I'm sure these are in the book somewhere. It doesn't matter what kind of control chart you're producing. You go through kind of essentially the same series of steps. Again, this is stage 1 or phase 1, where you're trying to determine whether this process is in control or not. In control is defined as it has a variability due to random causes, assignable causes, and out of control variability is due to both random cause and assignable causes. So the first thing to do is to figure out what kind of data you obtain from your process. If you are, because this determines what kind of chart you can use. Excuse me. So if I happen to like XBAR and R charts, but what I have is an assembly line, and I have an inspector at the end, and we're sewing children's sleepwear, and all the inspector can do at the end is to look at it and say, it looks good, it passes, or I see defects, so it doesn't pass. You can't get measurement data from that. So you're stuck with a P chart, an NP chart, or a C chart if you do that. So some other kind of chart. There are many more charts than the ones we're going to look at, but these are the ones we'll look at. Once you decide what kind of chart you're dealing with, you have to gather data from your process. And I put that taking at least 20 samples in there because the Western Electric Handbook of Quality, which is kind of the Bible of quality control, says you shall take 20 samples every time you do it. And I would suggest taking at least 20, probably more than 20, which might make your life easier if it turns out you've got some situation where one of your observations had assignable cause variability. We're going to use pH-stat to do all of our computations and create the chart. So you're going to open up pH-stat, then you're going to open up the raw data. You pick the correct chart type, answer the questions, and press OK, and bingo, it is going to create for you the center line, the upper, the lower control limits. It'll do all of this for you, plots them. If you were doing this by hand without pH-stat, you would have to actually get a piece of graph paper and do all this plotting yourself and all the calculations by hand. You have to, once you got everything plotted, then you look at your chart and you make a determination about whether this process is in control or out of control. And so if you see a single point outside your upper or lower control limit, it's out of control and you've got to fix it before you can use it. So once you have a process that is in control, meaning everything plots inside, you can begin to use this in phase 2 to monitor your process on an ongoing basis. The limits, I put that in there because in the book, some books I've seen, they will set limits at plus or minus 2 standard deviations. We will always use plus or minus 3 standard deviations. Schuhart's theory said that since 99.7% of all observations are plus or minus 3 standard deviations in a normal distribution, that's what he used to build control charts with. So we will stick with that. You shouldn't see anything in any of your homework assignments or test assignments that's anything different. So our first one on page 18-7 uses a file called hotel, and you see I've got all the calculations I have done by hand using my trusty calculator. This P chart, the P chart is a chart that looks at the proportion of defectives. In this first example, what we have are equal sample sizes. So I'm going to go to Excel. I'm going to open up the file called hotel and show you how much easier it is to do it in PHStat. So there's open. Here's my file. You can see that this is a hotel, and what they've done is for 28 days, they have conducted this study where they looked at 200 of their rooms, and they have counted the number of rooms that are not ready by some certain time during the day. All of you probably gone to a hotel and they've said, oh, the rooms are not ready yet. Well, this is, how many have violated this? So anyway, so to do this in PHStat is so easy. You go to PHStat, you look under control charts here on the right, and you're going to pick off, you've got a choice between a P, a C, and an X bar and R chart. So pick off the P chart. This particular example, all of our sample sizes are the same, 200 every day. So your non-conformances cell range is the number of rooms that are not ready. And you can pick off, in the case of the P chart, you can easily pick off the title. So my first cell contains a label, and my sample sizes doesn't vary. So all I've got to do is tell it there's 200 every time I place a sample, or took a sample, I'd sample 200. When we get our next example, our size will vary, and you just basically pick the sample sizes off. And then all you do is say, okay, and voila, there's your P chart. It created, and again, obviously for your homework and for your test, you're going to want to copy these things, paste them into the Word document. But here's your created chart. It gets calculations. This gives you your upper and lower limit, center line, standard deviation, well, 3 standard deviations, all your information. And then these are actually, if you were doing this in Excel, we'll see this when we get to our C chart, because it will not work right. You have to actually, if you do it in Excel, you have to actually have a column with the upper, the lower, and the center lines in it to create a chart. But we don't need that for our P chart. So you can see that we look at it, our center lines in the pink, at least it looks like on my screen, and all those little blue, they're connected, got to connect them. These show our actual observations. My upper and lower control limit are here, the dotted lines, and you will see that none of these points is outside the upper or the lower control limit. So for this particular problem, our conclusion would be that our process is in control, and we can now begin using our control chart. Anyway, so that's the P chart. Really easy to create. Much easier to do in PHStat than it is to do it by hand. He goes through an example in the book on page 18-8, example 18.1, I think it's 18.1, where he uses a file called Sponge. And this particular one is P chart, but you've got differing sample sizes. So you've got to go through a lot of hoops to get this done. So to do this in Excel, I open up the file called Sponge, and you will see for these sponges, they produce different numbers. You see the sample sizes vary every day, and they've got the number of non-conforming. So we just go to PHStat again, control charts, a P chart, and we just tell it our non-conformances cell range again is our non-conforming sponges, the ones that weren't good. And then we go down and we change it down here, and we tell it that our sample size varies. And we go back and we pick out the column with the actual sample size for each day's observations. And both of these first cells contain label boxes are checked. That is because I checked those things off. You just need to be consistent, I think, between them when you're doing it. And you just say, okay, and there's your P chart. Again, this one, we look at it again, same thing, our center line's in the pink, our upper and lower limit are these dotted lines, and you see right away looking at it that we've got a problem with this particular data. We have a problem in observation. You can point at it on day 26. Our proportion of defectives was like too high, outside our control chart limit, which tells us that something happened that particular day when they were producing the sponges, and you've got to go back and figure out what happened, because you've got to figure out how to fix it at that point. So anyway, that's our P chart. I didn't think I had a C chart. It says I do. Section 18.4, I do not have in my notes. 18.3 is the red bead experiment. You should really read that section carefully, because you need to understand what exactly is going on with that, because that kind of explains to you what happens when you overmanage a process. So anyway, I do not have the C chart in my notes. I'm sure I don't. Or maybe I do after. Yeah, here I do. I do. So a C chart is different than a P chart, in that what you're doing is, and the word that they always use is area of opportunity. So instead of taking a set sample size, what you're doing is you're defining this area of opportunity, and you are doing a C chart. So for instance, this example that he's got in the book on page 18-13 uses a file called complaints, and it's the number of complaints that were filed in the last 50 weeks. So every week they counted the number of complaints. There was no sample size to speak of, just, you know, a week at a time they counted the complaints. If I was producing corduroy fabric in a fabric mill, and I pulled out a yard of fabric and counted the defects, that would be a C chart. Okay, so our file is called complaints, and I am absolutely sure I do not have that. Oh, I do have that open. Anyway, complaints, and you'll see over the past 50 weeks, you know, these are the number of complaints that they had from this process. So when you go to PHStat, again, control charts, this is the one, at least on my PHStat, I have to go do a little bit of work and pretend I'm just doing Excel, but it does all of the calculations for you. It just will not create the chart. So my nonconformances cell range would be, again, the number of complaints. And first cell contains a label, and I say, okay, and weird things happen. First of all, it tells me there's unexpected error encountered when I created the chart. Just say, okay, don't argue with it, because it gives you your actual calculations. It computes your upper lower limit, your center line, and it gives you this lovely table here where it lists the number of complaints. It's just what you're going to actually plot, the lower control limit, the center line, and the upper control limit. So you can just go back to Excel, select these four columns, and go to home. Let's get out of that and go to insert. And what we're going to put in is a line chart. I think I just want that first line chart. So there is, you know, I can create it in Excel also. It's not as pretty as it is in PHStat, but you'll see that number of complaints is in the blue. My lower control limits is red line, not exactly, we usually just use dotted lines for that. And my upper limit is this purple line. So you can see, looking at it, that again, for a phase 1 study, it looks like this thing is okay. My complaints are all within my upper and lower control limit. Now, if I was in phase 2 with this, I'd be concerned, because in phase 2 study, you are looking for patterns in the data. And we haven't quite gotten there yet, but anyway, so you want to make sure that you know, you're looking for the right thing. Anyway, that's that part of the chapter. And what you should do is study and read it this week. And we'll do the XBAR R charts and the process capability next week. Okay? Thank you. Bye.